Welcome students. Today our topic is electrical welding. Welding is the process of joining two pieces of metal or non-metal together by heating them to their melting point. Filler metal may or may not be used to join two pieces. The physical and mechanical properties of a material to be welded, such as melting temperature, density, thermal conductivity, and tensile strength, taken as important role in welding. Depending upon how the heat applied is created, we get different type of welding such as thermal welding, gas welding, and electric welding. Hence, in this discussion or in this section, we will discuss only about the electric welding and some introduction to other modern welding techniques also. Now, unlike other traditional method of welding, electric welding required only a minimal amount of skill and understanding on the part of the dynamo operator. He must only learn the proper welding heat of the metal being used, but is not required to learn the more intricate process of conventional welding. The dynamo used in electric welding is self-regulating and only needs occasional lubrication to continue work properly. This make electric welding perfect for the novice welder, or we can say that the person who is in learn how to weld newly. Now, the advantages of the electric welding are the welding is the most economical method to permanently join two metal parts. It provides design flexibility. Welding equipment is not so costly and is portable. It permits considerable freedom to design. Both similar and dissimilar metal can be joined by welding, and the welding joints are easily to inspect also. So these are the advantages. The drawbacks of the electric weldings are welding gives out harmful radiation and fumes. Welding process required skilled operators. If welding is not done carefully, it may result in distortion of the workpiece, and welding need internal inspection also. Now, when we classified the electrical welding, you can see easily in this figure, that is the electric welding is classified into the two categories, that is resistance welding and the arc welding. The resistance welding is further classified into four categories, that is spot welding, seam welding, projection welding, and butt welding. And this butt welding is again classified into two categories, that is upset butt welding and flash butt welding. When we talk about the arc welding is also classified into four categories, that is carbon arc welding, atomic hydrogen arc welding, and helium arc welding, and metal arc welding. The proper selection of the welding process depends upon the following factors, and these factors are the type of metal to be joined, the technique to be welding which we are adopted, and the cost of equipment we are used, and the nature of product to be fabricated. So the overall welding process depending upon these four factors. Now we are starting with the resistance welding. The resistance welding is the process of joining two metals together by the heat produced due to the resistance offered to the flow of electric current at the junction of two metals. The heat produced by the resistance to the flow of current is given by H is equal to I square RT, where I is the current flowing through the electrodes, R is the contact resistance of the interface, and T is the time for which current flows. Here, the total resistance offered to the flow of current is made up of the resistance of current path in the work, the resistance between the contact surface of the part being welded, and the resistance between electrode and surface of part being welded. Now, in this process of welding, the heat developed at the contact area between the piece to be welded reduces the metal to plastic state or a liquid state. Then the pieces are pressed under high mechanical pressure to complete the weld. The electric voltage input to the welding varies in between 4 to 12 volt depending upon the area, thickness, composition, etc. And usually power ranges is about 60 to 180 watt for each square of area. We have a diagram here. We have two electrodes here, and we are supplying electricity by this step down welding transformer, and on this we are providing welded these two metal parts. Now, any desired combination of voltage and current can be obtained by means of a suitable transformer in AC. Hence, AC is found to be most suitable for the resistance welding. The magnitude of current is controlled by changing the primary voltage of the welding transformer, which can be done by using an auto transformer or a tap changing transformer. Automatic arrangement are provided to switch off the supply after a predetermined time for applying the pressure. Why? Because the duration of the current flow through the work is very important in the resistance welding. Now, the advantage of the resistance welding is that welding process is rapid and simple. Localized heating is possible if required. No need of using filler metals. Both similar and dissimilar metal can be welded. Comparatively less skill is required. Maintenance cost is very less, and it can be employed for mass production also. Initial cost is the drawbacks of this resistance welding are the initial cost is very high maintenance cost. The workpiece with heavier thickness cannot be welded since it required high input current. And the application of this resistance welding is it is used by many industries, manufacturing products made up of thinner gauge metals. It is used for the manufacturing of tube and smaller structure section also. The type of resistance welding, we have a four type of resistance welding, or we can say that we are classified into a four categories. So the type of the resistance welding are spot welding, seam welding, projection welding, and butt welding. Now, the spot welding means the joining of two metal sheet and fishing them together between copper electrode strip at suitably spaced interval by means of heavy electric current pass through the electrode as shown in the figure. So you see in the figure we have a step down transformer. With this help of this step down transformer, we are providing the supply here between the two electrodes. We have this metal part, and this point the metal is welded. So these two plates are welded together at this point. So after some time, or we can say that after a small distance, we are welded this plate. So this type of joint formed by the spot welding provides mechanical strength and not air or water tight. For such welding, it is necessary to localize the welding current and to apply sufficient pressure on the sheet to be welded. The electrodes are made up of copper or copper alloy and are water cooled. The welding current varies widely depending upon the thickness and composition of the plate. It varies from 1000 to 10,000 ampere, and the voltage between electrode is usually less than the 2 volt. The period of flow of current varies widely depending upon the thickness of sheet to be joined. A step down transformer is used to reduce high voltage and low current supply to low voltage and high current supply required. Now, when voltage applied across the electrodes The flow of current will generate heat, and at the three junction, that is heat develop between the two electrode tip and workpiece, between the two workpiece to be joined as shown in the figure. We see previously in the figure that two plates we are joining. The generation of the heat at junction 1 and 3 will affect electrode strictly and metal through holes. Using water cooled electrodes as shown in here in the figure, uh, by avoiding the heating of junction 1 and 3 electrodes in which cooled water circulate continuously as shown in here in the figure, the material used for electrodes should have high electric and thermal conductivity. Spot welding is widely used for automatic welding process for joining automobile parts, joining and fabrication, sheet metal structure, etc. When we look to the seam welding is nothing but the series of continuous spot welding. If number of spots obtained by spot welding are placed very costly, then they can overlap. It gives rise to seam welding. In this welding, continuous spot welding can be formed by using wheel type or roller electrode instead of tip electrode. You can easily see in the figure. In the spot welding, we have a electrode which is pointed. Now, seam welding is obtained by keeping the job under electrode when these wheel type of electrodes travel over the metal piece, which are under pressure. The current passing between them heat the two metal piece to the plastic state and result into continuous spot welds. In this welding, the contact area of electrodes should be small, which will localize the current pressure to the welding points. After forming weld at one point, the weld so obtained can be cooled by splashing water over the job by using cooling jets. Now, next is the butt welding. Butt welding is similar to the spot welding, however, the only difference is in butt welding, instead of electrode, the metal part are to be joined or butt together are connected to the supply. We have three type of butt welding, that is upset butt welding, flash butt welding and precursion butt welding. In the upset butt welding, the two metal parts are to be welded and are joined end to end and are connected across the secondary of a welding transformer. Here, as shown in the figure, you can easily see in this figure. In this figure, these two metal parts have to be joined at this point, and these are connected head to head. Due to the contact resistance of the metal to be welded, heating effect is generated in this welding. When current is made to flow through the two electrodes, heat will develop due to the contact resistance of the two piece, and then these contact are melts by the applying high mechanical pressure either manually or by toggle mechanism. The two metal pieces are pressed. When jaw type electrodes are used that introduce the high current without treating any hotspot on the job. This type of welding is usually employed for welding of rod, pipe, wires and joining metal part end to end. Now, next is the flash butt joint. Flash butt welding is a combination of resistance, arc and pressure welding. This method of welding is mainly used in production welding. A simple flash butt welding arrangement is shown in figure. We have a two metal piece, or we can say the two objects are there. At this point we have to weld together these two. In this method of welding, the two pieces to be welded are brought very near to each other under light mechanical pressure. The two pieces are placed in a conducting movable clamps. When high current is passed through the two metal pieces, they are separated by some distance and the arc is established between them. This arc or flashing is allowed till the end of the workpiece reach melting temperature. The supply will switch off and the pieces are rapidly brought together under light pressure. As the pieces are moved together, the fused metal and slag come out of the joint, making a good solid joint. The advantage of the flash butt welding are less requirement of power. When the surface being joined, it required only less attention. Weld obtained is so clean and pure due to foreign metal appear on the surface will burn due to flash or arc. Now that's all for today. In the next class, we are discussing about the arc welding.